Hello winners, this is Proshun sir, the chemistry teacher. I am here to deal with the part 2 of the gas laws of class 9 ICC board and also the class 10 standard of ICC board. Now we have already discussed about the Charles law. Today we will discuss about the Boyle's law. So in Boyle's law, temperature and other physical parameters, if they are constant, and if you consider a dry gas, then for that dry gas the pressure exerted is inversely proportional to the volume. Here lies the statement: temperature and other physical parameters remaining constant, the volume of the given mass of gas is inversely proportional to the pressure applied by the gas. If V is the volume, it is inversely proportional to P. That means V is proportional to kappa by P, kappa equal to proportionality constant or Boyle's constant. We can also write PV equal to kappa. So this is the mathematical formulation of the Boyle's law. We are numbering this as number 1. Now, if you see this graph, if you see this equation, it can be plotted in the graph. I am just coming to the graph. Now this is in general. Now for various conditions, you can always get it like this: P1 V1 first condition. I mean you are changing the conditions and just getting it. P2 V2 equal to P3 V3 equal to dot equal to Pn Vn equal to kappa. This is another statement of the Boyle's law. This is at various conditions, this is just in general. Now if you try to plot the graph between P and V, this is the graphical implications. You put V here and you put the P here. This is the graph. It is a rectangular parabola by nature. Figure 1, P versus V for Boyle's law. Obviously in the exam you need to write not to scale. Now if you take PV and P, you are taking PV and P, you get like this. If you take like this, PV and P, then also you get it like this. These are some of the graphs easily obtained. If you want to plot it, like now I am plotting it, P versus 1 by V, then you get a straight line like this. All for Boyle's law. 1, this is graph number 2, this is graph number 3, and this is graph number 4. So this equation is actually this graph. Or all these things, whatever. Now this equation number 2, P1 V1 equal to P2 V2 equal to P3 V3 equal to dot kappa. We want to plot it. The plot becomes like this. V here, P here. This is for temperature T1, the lower temperature. This is for a bit high temperature, T2. This is for a bit more higher, that is T3. Now T1, T2, T3 are the corresponding. Now this is the graph of Boyle's law at corresponding high temperatures, lower to higher. Now these graphs are called isotherms. Why? Because temperature is constant. Whenever we keep the temperature constant, we call it isotherm. Now we come to the implication of the Boyle's law. When we come to the implication of the Boyle's law, we deal with the density of any gas with respect to Boyle's law. If you try to calculate density, rho or d whatever. I prefer to write the term rho only. With respect to Boyle's law. With respect to Boyle's law. So density equal to mass by volume, right? M equal to mass, V equal to volume. Now you mark this equation number 1 from Boyle's law. PV equal to kappa or P equal to kappa by V or P by kappa equal to 1 by V. P by kappa equal to 1 by V. Equation number 2. You substitute this in this. So substituting equation 2 in equation 1, you get rho equal to m into 1 by v equal to m into p by kappa. You can always write rho equal to m by kappa. M is obviously constant into p. This is the relation of density with respect to Boyle's law. If m equal to constant, obviously it should be because it is the mass, kappa, Boyle's constant, must be constant, then m by kappa is also a constant. Thus we can write rho is proportional to p. That means density increases with the increase of pressure. This is a very common thing. So this is what I need to speak about the Boyle's law. This is the statement of the Boyle's law, and this is the equations of the Boyle's law, and this is the implication of the Boyle's law, that is the density that we are calculating. And graphs I have already drawn. So I hope everything is clear now regarding Boyle's law, and still if there is any question regarding something, or you want something else, you can obviously just put a comment. Accordingly we can work up. So I'm ending my video here. I hope it is clear to everybody. So good night to everybody. Jai Ma Bharati.